Welcome back to Introduction to Programming. This is video 15 in our series. My name is John Duane. In the last two videos, we talked about looping techniques and how they are essential tools in dealing with large data sets. We even saw an example of using a simple loop to search for a zip code in a worksheet of about 50,000 zip codes. The other incredibly powerful tool that will help you deal effectively with large data sets is something I call in-memory data structures. If we were to have searched the zip code list from an in-memory data structure, it would have been much faster than the linear search down the column in the worksheet. And usually in creating computer programs, faster is better. So that brings us to today's topic, arrays. We will go over what arrays are, how you implement them in code, and we will have a few examples. In the next video, we will devote the entire video to a single program that analyzes U.S. Census data using loops and arrays. So that'll be a great practical example. Let's cover some basics first. Remember that a variable is a data container and it has a location in memory. The variable name is actually a pointer to that memory address. This variable is a container of a single thing, a number, a word, a single text character, true or false. Arrays are very similar, except that they are data containers for multiple items. And usually these items are related, kind of like what you see on the screen here. This looks like an array of household pets. The name of the array is a pointer to a group of contiguous bytes in memory that hold these individual related items. So what you see on the screen here is a pictorial representation of a four-element single dimension array. Think of it as a row or a column of data. Okay, let's look at our first example. So in this example, we have a single dimensional array or a one-dimensional array. The data type is string. There are 5 elements, and you can see that with this parentheses. So the way the notation works, when you declare an array, you give it a name kind of like you would a variable, but then what's different is this parentheses with the numbers inside. The parentheses tells the compiler that it's an array, and the numbers inside tell the compiler how big to make it, how much memory to allocate. In this case, it's 5 string characters, so that'll be 10 bytes per string times 5, so it'll be 50 bytes. Now down, I've actually declared it twice. We can get rid of this one. You only need to declare arrays once. So that's the declaration. Here's where we assign values, and we assign values with this notation. That's an index number. So that's how you differentiate the items in an array, is with the index numbers. And so to array element 1, we're assigning the capital I, and so on. So after we've assigned the values, how do you get values out? Well, do it like this. Here's a for next loop where I'm going to iterate through all the elements in the array. There's 5 of them, so for I equals 1 to 5, so I'll loop 5 times. Each time I'll print the ith character, that is whatever I is, so it'll be 1 through 5, and they'll appear in the immediate window. So let's run that. You can see what that looks like. And there you go. It printed them out like a sentence, except in sort of vertical orientation. So there you go. That's a fairly simple one. All right, our next example is going to be for a two-dimensional array. So that's a little more complex. You see an example of a two-dimensional array on the screen here. Think of it as rows and columns. That's the way I keep it straight. In memory itself, it's probably just one long contiguous sequence of bytes, but to think about it, I think it's best to think about it as rows and columns. where a single dimensional array is really just a row or just a column. So let's look at our example for this. All right, this one's going to be a two-dimensional array. Let's paste that in. Don't need that anymore. Two-dimensional array where in the there'll be 5 rows, so 1 through 5, and then 2 columns. Now the columns will represent drivers and cars. So notice the notation. The first number is the row, the next is the column. So in row 1, column 1, we'll have Ricky Bobby, and then in row 1, column 2, we'll have what his car is, a Ford, and then so on down the line. So that's the notation, and then similar notation to get the values out. Instead of actual numbers, now we're going to use a variable for the row and an actual number for the column, and we'll loop through 5 times to get all 5 pairs of data. So let's run that and see what that looks like. And there we go. So Ricky Bobby Ford, Jimmy Chevy, Dale Dodge, Richard Pontiac, Danica Mercury, and that makes sense. So row 1 has Ricky Bobby and Ford. Good. Let's do one last example. So those first 2 examples used strings. This example will use numbers. Okay, so again, we have a two-dimensional array, 5 rows, 2 columns. This one's called ARR factors. Notice that I did not declare the size of the array in this first dim statement as I did previously. Sometimes, and actually often, you won't know the size of the array at the very beginning of the program. You'll have other procedures later on which will figure out how big it needs to be. So you'll resize the array later on. And when you do that, you use this redim keyword. We're filling the array this time with a for next loop. So that's a little different. And this is not just one for next loop, it's 2. So there's an outer loop and an inner loop. We call this a nested for next loop. So this outer loop will loop 5 times, but for each time it loops, this inner loop will go twice. Right? So you see 1 to 5 and 1 to 2. And then we have different counting variables for each. So this is a great example of how the counting variables in for next loops can also be used as the index numbers in the arrays. Notice that the array numbers that we're using here in this assignment statement are not numbers now, they're variables, I and j. What we're assigning to the array element is the value in this function, timer. This is the number of seconds past midnight, used in all sorts of like timing functions, but it's a good way to get sort of a random number or a different number. I needed to add this other line which will cause the program to delay about a second. Probably delayed maybe about 10 seconds altogether. If I didn't do that, I would get the same exact number in every array element since the program goes so fast. So that pause will help us get different numbers. And then as we did before, we'll print them all to the immediate window. And here we're going to do a mathematical calculation. We're going to add the 2 numbers together, the 2 array elements. So that'll just show you one more thing you can do with these array elements. So let's run this. Like I said, this will take a few seconds because of all the delays I put in there. And there we go. So it printed the result of 5 mathematical calculations, and you can see that the numbers are increasing as we get farther away from midnight. All right, good. Okay, so that's it for the examples. Let's kind of wrap this up. Today we have seen another fundamental building block for your computer programs, the array. It is a basic in-memory data structure that all computer languages have. They can be either single dimension, just a column, or multi-dimensional. The most common multi-dimensional is 2 dimensions, rows and columns. But you can also have 3 dimensions. That would resemble a cube. Now, since arrays are in memory, they're very fast. That's why they're used as much as they are. But because they're in memory, if you allow them to get too big, they can slow down your program because they're using too much memory. But they have to get pretty big for that to happen. Now, I haven't mentioned any other types of in-memory storage. In the more modern programming languages such as Java and C#, there are many very handy data structures that solve some of the problems that arrays leave for the programmer to solve on his or her own. You can see this is kind of a cool diagram of all the different types of data structures out there. But going back to the problems that arrays create, an example is regular arrays require that you know ahead of time how many elements will be in the array. That means the programmer has to count the items first, size the array properly, and then put the items in the array. That's very time consuming. The newer languages have structures called collections, array lists, I think that's on here somewhere, and dictionaries, hash tables that don't have this limitation. And we'll see at least one of those in a future video. So that's it for today. I hope this was helpful. Please subscribe to this video series and write comments about anything that was not clear. I will monitor the comments and I will definitely respond. So we'll see you next time.